So now that we understand the particle level, let's work through a Stoich problem. Just like any Stoich problem, we're going to need to write our balanced equation first. And I'm going to write some gaps here, and it'll make sense in a minute why I'm doing that. So I have hydrogen gas plus oxygen gas yields liquid water. When I balance it, I know that for every 2 moles of hydrogen reacted with 1 mole of oxygen, I produce 2 moles of water. And so to determine what our limiting reactant is, we're going to use our mole concept. The first thing we need to do is figure out if one of these were my limiting reactant, how much of the other would be required. And so to do that, I'm going to scan down a little bit here. And I'm going to say, I'm just going to pick what comes first. If I were to use 1.25 moles of hydrogen, if that's what got all used up and was my limiting reactant, how many moles of oxygen would I need? And so I'm going to do 1.25 moles of hydrogen. I'm going to do mole ratio and compare moles of hydrogen to moles of oxygen. By using my balanced equation, I know that for every 2 moles of hydrogen, I require 1 mole of oxygen. So then I'm just going to type this into my calculator and see, do I have enough oxygen to do this reaction? And I find that I would require, if I do this ratio, I would require 0.625 moles of oxygen. When I look at my problem tells me that I only have 0.46 moles of oxygen. So since my 0.46 moles is less than the 0.625 required to react with all of the hydrogen, that tells me that my oxygen is my limiting reactant. 0.46 moles of oxygen for every 1 mole of oxygen, I produce 2 moles, or I require 2 moles of hydrogen. And so now when I do that, I find that I would require 0.92 moles of hydrogen. Since I have 1.25 moles, that means that the amount of hydrogen required is less than the amount that I have. So that's going to be my reagent in excess. My limiting reactant is the one that I use up entirely. And so this is going to be the formula we use. In order to figure some things out, we're going to do what's called a BCA chart. B stands for before, C stands for change, and the A stands for after. And so the before is exactly that. How much did I start with? So in the lab, I actually measured out 1.25 moles of hydrogen. I measured 0.46 moles of oxygen. And how much water did I have? Well, it's before the reaction happened, so I have 0 moles at the start because it's before the reaction happened. Therefore, I have nothing at the start. So your products are always going to be 0 for your before. The change is how much you're using. And so, remember we said we're going to use this formula because my oxygen was my limiting reactant. And so that tells me that I'm going to use, and since I'm using it up, it's going to subtract. I'm going to use 0.46 moles of hydrogen. Would help if I could read, wouldn't it? I'm going to use 0.46 moles of oxygen. I'm going to use 0.92 moles of hydrogen. 0.92 moles of hydrogen, 0.46 of oxygen. And so now, well, how much water is made? We're going to do another mole ratio. So in this case, I can look and I notice that for every 2 moles of hydrogen produced, I produce 2 moles of water. And since I can compare moles directly, that tells me that I'm going to produce 0.92 moles of water. Don't believe me? Let's try it. So for my hydrogen, I used 0.92 moles of hydrogen. Doing my mole ratio, for every 1 mole of hydrogen, for every 2 moles of hydrogen, I produce 2 moles of water. The 2 moles cancels out, and so I end up with 0.92 moles of water. So, because I can compare those coefficients and those coefficients are the same, that means that the amount on the change in the negative is going to be equal to the amount of change in the positive for my product. So you are always going to subtract your reactants because it's being reacted, it's being used up, and you're always going to have a positive for your products because it's being produced. I'm adding it. The after is a simple subtraction problem. And so I'm going to take my 1.25, subtract 0.92, and I get that I have 0.33 moles left over. My oxygen, I used all 0.46 moles, so I'm going to have 0 moles of oxygen left. Your limiting reactant should always be used entirely. It should always have 0 moles left over. And for my products, I had 0.92 moles produced. That's how you do a limiting reactant problem. In the next video, part 2, I'm going to do a problem where we start with grams. I hope this helped.